everyone. This is the second part of the lesson for section 6.3 in Algebra 1A, and we're picking up talking about some different properties of parabolas. Now, I've been teasing you for the whole first half of the lesson that I would tell you what the A value does to the graph, and this is where we're going to get into that. One quick thing to write down first. Our parabolas can look like this, or they can look like this. Okay, basically they can be right side up or upside down. Okay, when they look like this, we say that this opens up, because the opening is at the top. And we say that this one opens down. Okay, which shouldn't be, whoops, I'm gonna run out of space there. Shouldn't be too earth-shattering, right? One face is up, one face is down. So that's not big news or anything. What is important to understand is that, I can't spell. What is important to understand is that when a parabola faces up, its vertex is down at the bottom. And so we call that a minimum point. And when a parabola faces down, the vertex is at the top, so we call that a maximum point. So sometimes what's going to happen is I'm going to hand you an equation, and I'm going to say, does this thing have a minimum or a maximum? And just keep in mind that really what I'm asking you at that point is which way does it face? Okay, if it faces upward where the arrows are pointing up here, then the vertex is going to be a minimum value. If it's facing downward like this, then the vertex is going to be at the top and it'll be a maximum value. Okay, so what controls that is that A value that we talked about. So when the A value is positive, so let's see. I guess I'll do this. When the A value is positive, our parabola is going to open upward. When our A value is negative, it's going to open downward. And the reason I stumbled over my notation there is a lot of the times in math, the way you see this written is A is greater than 0. I just wanted to kind of drive home the point that that's the same thing as A being positive. If I say A is negative, that's the same thing as saying A is less than 0. Okay? And that's going to give you a downward facing parabola. Okay, the other thing that A does, A controls something else about your parabolas. It controls how wide or how skinny your parabola happens to be. So if you think about that last example we did on Desmos, and actually maybe I still have it sitting here. Okay, this example here, this came out to be a super skinny parabola. That's because my A value was 4. Okay, if I took that 4 out of there, watch what's going to happen. That parabola is going to get wider. Okay, if I put a 6 in there or an 8, it's just going to keep making my parabola skinnier and skinnier and skinnier. So the larger your A value is, the skinnier your parabola is. Okay, that's kind of important to know. So let's write down, and I'm going to write this kind of up the top here, I think. Anytime A is larger than 1. So keep in mind that if there's not an A value written there, that's when A is exactly equal to 1. That's kind of your normal sized parabola. When I make my A larger than 1, my parabola gets skinnier. When I make my A value less than 1, my parabola is going to get wider, and I'll demonstrate that for you in just a second. I'm being a little lazy with my notation here. I should really point this out, because yes, if it's greater than 1, it's going to be skinny. But if I were to do something like make it a -3, let's pull that back up. Where'd my Desmos go? Okay, so right now we have our A value in here at 10. If I make it a -10, notice it's still a very skinny parabola. It's just upside down. And we knew that because we know that the A value being negative is what turns it upside down. Okay, technically -10 is not larger than 1. But if I kind of disregard that negative sign and just think about the number itself, the 10, that is larger than 1. So the value of the A value, so the absolute value, I guess I should say. So really what we should be saying in our notes here in this notation is that the absolute value, when it's larger than 1, we're going to have a skinny parabola. And with our A value being less than 1, but if it stays above -1, so really we're talking fractions and decimals here, that's when my parabola is going to be wide. Okay, So for example, a -2. -2, the absolute value is larger than 1. Okay, so that's going to be a skinny parabola, and upside down because it's negative. If I have an a value of -0.5, -0.5 is going to fall in this range between -1 and 1 in those fractions and decimals, and that's going to be a wider parabola than average. Okay, so let's go back here and let's look at just plain old y equals x squared. Let's look at this guy back here. If I put in a 2, this thing's going to get skinnier. And maybe I'll do this. Maybe I will leave y equals x squared on there and give you this one for reference. Okay, so 2x squared is going to get skinnier. 3x squared is going to get skinnier than that. 10x squared is going to get skinnier than that. So the larger my a value gets, the skinnier it is. Okay. Also, if I take my a value and turn it negative, so negative, if I make it just -x squared, it's exactly the same width, it's just upside down. And now if I start throwing in -2, -3, -5, and so on, okay, that's making my parabola skinnier and skinnier and skinnier. The negative is just making it turn upside down. On the flip side to that, if I make it like a 1/2, notice it's getting wider. Okay, so anything smaller than 1, 1/3, 1/5, 1/10, those are all wider than the original parabola. Okay, so that's another thing that the a value affects when we're looking at these quadratic functions. Oh, keep doing that. No. Okay, guys, there we go. Okay, so take a look at this example 4 here. This just wants us, this kind of pulls it all together. We're going to try to sketch a graph of this thing. We're not going to plot it point for point, but there's some important pieces that we can pull out of this equation. So first thing I should be able to identify is, where is the vertex located? Remember, the vertex is h and k, which are here and here. And remember that when I'm looking at the equation, my signs are backwards. So my vertex would be at -2, +4. Okay. My a value is equal to 1/2, and I can pull 2 pieces of information from that. My a value being 1/2, because it's positive, that means it opens up. And because it's less than 1, I know it's going to be wider than average. Okay, so here's how I'm going to sketch this. I'm going to go to approximately -2, 4. We'll just say that's here-ish. And I'm going to draw a parabola that's wider than average and pointing upwards. So I might go something like this. And that, by the way, is what I expect on your homework. I expect you to be able to locate the vertex, know which direction your parabola should point in, and know whether it's wider or skinnier than average. Okay, I'm not going to get out a ruler and decide if it's wide enough or skinny enough. Just do enough to convince me that you know which one it should be. Okay, that's it. This is a big lesson. There's a lot of stuff going on in this one. So, take your time on that homework assignment. It's really not very difficult stuff, but there is definitely a lot of information to pull together. So feel free to ask questions if you've got them, and I will see you in class next time.